Hello everyone. Good evening. Yeah, we'll just start in a minute or so. Just hello everyone. I hope your exams are going well. Uh, Also, the preparation for our the coming exams is also going well because uh, we know that the IIM Bangalore UG entrance exam will happen in this year itself. Hopefully, sometime in December. And these classes that we're doing are basically aimed at that exam. So a lot of discussion on topics that otherwise you will not pick up in different classes because of level of difficulty or whatever. A lot of discussion on higher maths, critical reasoning, and I think a lot of practice as well is what we will do through these sessions. As was shared earlier, typically 3 days a week sort of a plan. But again, that can be altered. For example, since you're having your school exams right now, you're doing 2 sessions this week. From next week onwards, we ramp it up to 3. uh, Typically, it will be a good idea that since the topic is shared with you, it might be a good idea that you, at your end, do some sort of a pre-read before you attend the session. So you will be in a position to answer questions better, at least attempt questions better. If there is a gap, that can be filled here, right? Uh, Again, the sessions will be available for you to refer whenever you want. So in your preparation plan, revision plan, wherever the need for it feels, you can just go through the session again, right? Now, the topic that we cover today is a specific topic in numbers, which is remainders. There are many different types of questions that you will see in the topic of remainders. There is successive division. There is pure out and out questions on remainders. There are questions on divisibility and so on. So we'll understand what remainders are, what is the concept of positive negative remainders, what is successive division, and so on. And from there, see how we can apply these concepts to find out remainders when powers are divided by divisors. Since I'm going to talk about remainders, I think it makes sense to start from the concept of division itself. So, just to start, no, we'll start from checking divisibility tests. So, what is the divisibility test for 2? I understand all of us or most of us will know this, but again, I think the remainder starts showing from here. So, what is the divisibility test for 2? The last digit for of the number should be 02468 or an even digit. If that happens, the number is divisible by 2. Now the question is, what if that last digit is not 02468? If the last digit is 13579, then what happens? Then we get a remainder, right? So for example, if I say I am dividing 15 by 2, what will happen? So 2 will divide 15 7 times over. 7 2s are 14, and 1 will be left out. So that becomes the remainder. So if I'm dividing something by 2, two cases are possible. Either the number will be divisible, which will leave a remainder of 0, or the remainder will be 1. Divisibility test for 3, we find the sum of digits of the number. If the sum of digits is divisible by 3, the number is divisible by 3. If the sum of digits is not divisible by 3, the number is not divisible by 3. What happens if the number is not divisible by 3? There will be a remainder. And what could be the remainders? Again, if I say, suppose 58 divided by 3, 8 plus 5 is 13, and 13 is not divisible by 3. leaves a remainder of 1. So 58 will also leave a remainder of 1. If I say 59, 5 plus 9 is 14. 14 is not divisible by 3, leaves a remainder of 2. So 59 will also leave a remainder of 2. 60 becomes divisible by 3. So if I'm dividing a number by 3, the remainders could be 0, 1 or 2. 0 when the number is divisible by 3. Divisibility test for 4. In case of 2, we check the last digit. In case of 4, we check the last 2 digits as a number. If the last 2 digits are divisible by 4, the number is divisible by 4. Otherwise, whatever remainder we get will be the remainder for the number also. On dividing any number by 4, the remainders that you can get are, for example, if I look at 5, 6, 7, 8. So for 5, the remainder is 1. For 6, the remainder is 2. For 7, the remainder is 3. 8 is divisible by 4. So when you're dividing by 4, the remainders will be 1 less, 0, 1, 2, or 3. And this is true for any number. When you divide a number by n, you can get any remainder from 0 to n minus 1. For 5, the last digit should be 0 or 5. For 6, 6 is a composite number. So we look for 2 and 3. If a number is divisible by 2 and by 3, it will be divisible by their LCM as well. And LCM of 2 and 3 is 6. Therefore, the divisibility test for 6. How you find the remainders for 6 is something that we'll do today as well. Divisibility test for 8 then. For 2, I check the last digit. For 4, 2 square, we check the last 2 digits. 8, 2 cube, we will check the last 3 digits. If it were 16, 2 raised to power 4, we will check the last 4 digits. Test for 9, again like 3, sum of digits should be divisible by 3 by 9. Test for 10, I think is a very difficult question, so let us just leave this. Test for 11. You look at the number, you start from the units digit, call it u, and add the alternate digits. Then we start from the tens place and add the alternate digits. Then we calculate u minus t. If u minus t is 0 or a multiple of 11, the number is divisible by 11, otherwise not. So now I have an example for you. So this is the number that we have. 3, 4, 6, 7, 5, 2, 4, 2, 1, 5, 8, 4. We are checking divisibility by all the numbers. Is this divisible by 2? Last digit 4, therefore divisible by 2. Is it divisible by 3? We add the digits. Either I can add all the digits, or what I can do is I can remove groups of 3. So 3, 6, 7 plus 5, 12. All of this is divisible by 4. Or 4 plus 5, 9, 7 plus 2, 9. 4 plus 2, 6, 6, 12. And therefore, it will be divisible by 3. If I add all the digits individually, 3 plus 4, 7 plus 6, 13 plus 4, 7, 20, 25, 27, 31, 33, 34, 39, and 12, 51. 51 is 5 plus 1, 6, divisible by 3. Divisibility by 4. The last 2 digits are 84, so divisible by 4. Divisibility by 5. The last digit is 4, so not divisible by 5. What will be the remainder then? If this last digit was 0, the number would be divisible by 5. If it were 5, it will be divisible by 5. Since it is 4, the remainder becomes 4. Divisibility by 6, because divisible by 2 and 3 both. So divisible by 6 as well. Divisibility by 8. So we check 584. 8 sevens are 56. And then 2 divisible by 8 as well. 51, divisibility by 9. 51 divisibility 9, if I check, it is not 9 5 is 45. 45 and 51, there is a difference of 6. So the remainder of this number when divided by 9 will be 6. Divisibility by 11, we start from 4, the unit digit number, and add the alternate digits. So 4 plus 5, 9, plus 2, 11, plus 2, 13, plus 7, 20, plus 4, 24. Then we start from I call it U. Then we start from 8. Tens place number 8 plus 1, 9, plus 4, 13, 18, 24, 27. So U is 24, T is 27. I find out U minus T. Please note, when we are checking for divisibility by 11, I am not doing larger number minus smaller number that we intuitively will do. I am saying u minus t. U minus t is 24 minus 27. So the remainder will be 24 minus 27, which is minus 3. If the difference were 0 or a multiple of 11, then it would have been divisible. Now, what does the remainder of minus 3 mean? We will talk about it in a bit. But for now, a negative remainder simply is 11 minus 3, which is 8. Sorry, just a second. Yeah. So, we will talk about the concept of negative remainder today as well. Next. This is the equation that we have. Dividend is equal to divisor into quotient plus remainder. For example, when I divide 15 by 2, so 15 is equal to 2 into 7 plus 1. The number that is being divided is a dividend. The number which is divising is the divisor. And therefore, if I say there is a number which on dividing by 7 leaves a remainder 5, what will be the general form of that number? A number when divided by 7 leaves a remainder of 5. 7 is the divisor. The quotient could be anything. 5 is the remainder. So such a number will be of the form 7k plus 5. We will use this concept later, so therefore I am mentioning it now. And as I said, if I am dividing a number by 7, the remainders could be anything from 0 to 6. Now, the first concept that we will use for remainders. If x leaves a remainder of 6 when divided by 7, so x could be 7 plus 6, 13, x could be 14, 20, 27 and so on. And y leaves a remainder of 5 when divided by 7. So for x, the general form is 7x plus 6. For y, the general form is 7b plus 5. We have to find the remainders for the following cases. X plus y, x minus y, x into y, and x square plus y square. Just to avoid confusion, I am saying that I am giving you the information that x is greater than y. So what happens? See, x for me is a number of the format 7a plus 6. Y for me is a number of the format 7b plus 5. Right? I can choose a value of x and y, or I could continue like this. Just to make it easier for me to understand and not be confused by the variables, I am saying let the value of x be 7 plus 6. I'm taking a as 1, so 13. Y is 12. B also 1. So x plus y will be 25. And 25 by 7 is a remainder of 7, so 21, remainder 4. X minus y, 13 minus 12. 1 divided by 7 will be a remainder of 1. X into y, 13 into 12. 13 into 12 will be how much? 12 into 12 is 144. 144 12, 156. 156 divided by 7. 7 2s are 14. 7 2s are 14. So a remainder of 2. X square, y square. 13 square plus 12 square. So 169 plus 144. This becomes 313. If I divide that by 7, 7 4s are 28. A remainder of 5. So basically the remainders that I'm getting are 4, 1, 2, and 5. a lot of calculation here, but yeah, these are the remainders that I'm getting. Now, instead of 12 and 13, if I just use 6 and 5, x plus y, 6 plus 5 is 11. 11 divided by 7 will also give me a remainder of 4. If I just erase this part for a bit, the calculation part. Hmm. 6 plus 5 is 11, a remainder of 4. 6 minus 5 is 1, a remainder of 1. 6 into 5 is 30, a remainder of 2, and divided by 7. 36, x square. 6 square is 36. 5 square, 25. 36, 28, 61, divided by 7 is a remainder of 5. So what I'm trying to say is, in case of remainders, when the divisor is same, whatever the numbers will do, the remainders will do the same. So when I say that x is a remainder of 6, y is a remainder of 5, x plus y divided by 7 will be a remainder of 6 plus y divided by 7. So I just need to deal with the remainders, not the entire number. And therefore, on that basis, we get our first question. Remainders behave like the divisors, sorry, like the dividend over addition, subtraction, and multiplication. And therefore, this is the first question, which says 4831 into 4833 into 4835 is divided by 24. What is the remainder? Four eight three one, 4833, 4835. Clearly, what I cannot do is I cannot multiply these numbers, because if I do that, I'll not be able to do anything else. Right? So what I do, I find out the individual remainders and then multiply the remainders. So if I say 4831 by 24, see 4800 is divisible by 24. So is 24. So 4824 will be divisible by 24. So the remainder here will be 7. 4831 plus 2 is 33. So the remainder will be 7 plus 2, 9. And here 33 plus 2, 35, remainder will be 11. So basically the remainder will simply be 7 into 9 into 11. But as I can see, this is a number which is more than 24. So we solve further. 24, 48, 52. So what I do is I say 7 into 9 is 63. 63 divided by 24. This will be how much? 24 2s are 48. 48 and 63 is the remainder of 15. So from here I get remainder 15. Multiply by 11 again. 15 into 11 is 165. So finally I just check for 165 divided by 24. If I check with 7, 7 for the 28, 8, 2. 168, so I put 6, 144. The overall remainder here will be 21. Right? So the remainders behave like the dividend over addition, subtraction, multiplication. This is question number 1, or rather question type 1. Then the second type of question. This is related to successive division. What is successive division? I start with the number and keep dividing the quotient again and again. So the number reads, a number when divided by 4, 5, and 6 successively leaves a remainder of 3, 4, 2 respectively. What will be the remainder when the number is divided by 120? Just to explain to you what this question means, I am taking an example. Suppose I take a number n, which has a value of 120. Uh, 32. Say 150, 155. I am dividing this successively by 4, 5, 6. So what I'll do is I'll divide it by 4 first. So I get a remainder of 3. Then I'll take this quotient divided by 5. Again I get a remainder of 3. Then this 3 will be divided by 6, which in itself will give me a remainder of 3. Sorry, this quotient will be divided by 6. This 7 will be divided by 6. 6 ones are 6. So a remainder of 1. So when 155 is successively divided by 4, 5, 6, the remainders are 3, 3, 1 respectively. That is the idea of successive division. In my question, the remainders are 3, 4, 2. Now that number, which can be many such numbers will satisfy this. I have to see what will be the remainder when that kind of a number is divided by 120. Any answers? So in a question like this, what we'll always do is we will start from the reverse. Rather than dividing by 4, we will first look at the last step. The last step was division by 6, right? Therefore, the last quotient before division by 6 or the dividend would be 6k plus 2. When this is finally divided by 6, I'll get a remainder of 2. This will be the quotient of the previous division when I divided by 5. And therefore, the number before this will be 5 divisor into quotient plus remainder. This will be the quotient for the first division. Therefore, the original number will be 4 into quotient plus remainder. So we've just written all the steps in the reverse order. 6k plus 2, 5 into 6k plus 2 plus 4, 4 into 6k plus 2 plus 4 plus 3. Remainders 3, 4, 2, divisors 4, 5, 6. This can be repeated without any exception. Now, if I open the brackets, 30k plus 10 plus 4, 30k plus 14, 120k plus 56, 120k plus 59. So this becomes the general form of my number. Put any value of k, we will get this kind of a number. What will be the remainder when this is divided by 120? If I divide this part by 120, the first part will be divisible and the only remainder that I'll get will be from here. So this divides, leaving a remainder of 59 for me. Successive division. This has been a question in many exams. The steps will remain the same. A variation in this question could be a number when divided by 4, 5, 6 leaves remainder 3, 4, 2 respectively. What will be the remainders when the number is divided by 6, 5, 4 successively? So there, I will divide this by 6 first, get the quotient, divide that by 5, and then by 4, the reverse order. Then the idea of negative remainder that we got when we divided 11. We checked for divisibility by 11. So what is the idea of negative remainder? Since we look at numbers on a number line, their relative positioning gives it a positive or a negative value. So for example, if I say we divide 19 by 5, we'll get the quotient as 3 and the remainder as 4. But what if I make the quotient 4? So these are the multiples of 5. 0, 5, 10, 15, 20. There is a number 19 somewhere. So if I look from quotient 3, that is 15, the difference is 4. But if I look from 20, the difference will be 1. The sum of these two differences will always be equal to the divisor. 4 and 4 plus 1 will be 5. But when I'm moving from 20 to 19, I'm going in the opposite direction of the number line. Therefore, it becomes negative. So for every positive remainder, there will be a corresponding negative remainder. If the negative remainder is minus 1, when divided by 5, the positive remainder will simply be 5 minus 1, that is 4. Again, without any exception, this can be done. Therefore, a negative remainder minus r is equal to positive remainder, which is divisor minus r. Again, I'll be using this for questions. So whatever we've done till now, the remainders behaving as dividends, the concept of negative remainder we'll now use to solve questions, and with every question increase a step. So what is the remainder when 7 is divided by 6? This is a difficult question. Remainder 1. And therefore, if I say what is the remainder when 7 raised to the power 35 is divided by 6? Again, 7 divided by 6 was orally done. So 7 raised to the power 35 divided by 6 should also be oral. Because when I look at 7 raised to the power 35, it is 7 into 7 into 7 into 7 into 7 35 times. When I divide by 6, each of the 7 will give me 1 as the remainder. So the final remainder will simply be 1 into 1 into 1 into 1 into 1, which is 1 raised to the power 35, which is nothing but 1. So 7 raised to the power 35 by 6 can be looked as 6 plus 1 raised to the power 35. So I'll get 1 as the remainder every time. So overall remainder 1 raised to the power 35, which is nothing but 1. So we change the question now. What is the remainder when 5 raised to the power 36 is divided by 6? Very good. हाँ, -1 को पॉजिटिव कर दो. So when I look at 5, every time 5 is divided by 6, I will get remainder as 5 or -1, right? So every time I get -1 raised to the power 36. So here what I'm saying is, I write 5 as, 6 minus 1 raised to the power 36. Now every time I divide 6 minus 1 by 6, I get -1 as the remainder. So the overall remainder will be -1 36 times. What is -1 raised to the power 36? Yes. And therefore, because it is an even power, the answer will be 1. Perfect. Right? So we look at two cases. When the dividend was divisor plus 1, the power will not matter. When the dividend was divisor minus 1 and the power was even, what happens now? Remainder when 5 raised to the power 35 is divided by 6. Now the answer will be So typically, if you get this question in the exam, the answers or the options that you will have are 1, 0, 5, none of these. Typically in the exam, options are not a negative. Again, like the previous case, we will get -1 as the remainder. 5 is written as 6 minus 1. 6 minus 1 raised to the 35 divided by 6. So the remainder that I'll get is -1 raised to the 35. The remainder will be this part, which is nothing but -1. Since I'm getting a negative remainder, I will take this and add it to the divisor. And therefore my answer becomes 5. ठीक है? चल, अब और इसमें वेरिएशन लाते हैं. What is the remainder when 25 raised to the power 56 divided by 6? Because earlier we were getting the answer is 1. So positive answer करने कोई दिक्कत ही नहीं है. नेगेटिव में अगर -1 आएगा, we will add it to the divisor because option में -1 नहीं लिखा होगा. चलिए, 25 raised to the power 56. Again, similar to the previous questions. Basically, all I need to do is I am looking at the remainder from here to be a 1 or a -1, right? अब 25 by 6 अगर मैं देखूंगा तो 6 4 से 24 होता है. So I can write this as 24 plus 1 raised to the power 56. इसको हम 6 से डिवाइड कर रहे हैं. 24 is divisible by 6. So the remainder that is left is 1 raised to the power 56, which is 1. Because 25 leaves a remainder of 1 when divided by 6, 25 raised to the power 56 will leave the same remainder. So the first kind of questions are where I break down the numerator into divisor plus -1, right? And then according to the power, I might get the answer as 1 or -1. अब डिवाइड जो न्यूमरेटर है उसका बेस ही बहुत छोटा है. रिमाइंडर व्हेन 2 raised to the power 45 इज डिवाइडेड बाय 31. अब मेरे को जो न्यूमरेटर था उसको डिवाइजर +-1 में करना था. So the numerator has to be more than 31 at least. So what can we do? To ensure that the numerator dividend का जो base है that is more than 31, we will start raising the powers of 2. अब 2 की powers क्या क्या होती है? 2, 4, 8, 16, 32 है ना? और which power is 32? 2, 4, 8, 16, 32. 2 की power 5 is 32. So what I am doing here is I am saying यहां पे से 2 raised to the power 5 निकाल लो. बाहर क्या बचेगा? 45 by 5 is 9. 2 raised to the power 5 is 32. Can we find the remainder now? 32 can be written as 31 plus 1. The remainder will simply be this part. तो अगर न्यूमरेटर का बेस छोटा है, स्टार्ट रेजिंग पावर्स. इसका एक और वेरिएशन अब हियर. अभी क्या था? आई नीडेड 2 raised to the power 5 in the numerator, and from 2 raised to the power 45 I could take out 2 raised to the power 5. But what if the power for 2 is 48? 48 is not divisible by 5, that is the problem. So what will be the remainder when 2 raised to power 48 is divided by 31? Obviously, I want the numerator base to be close to 31. 32 plus 31 plus minus 1 ही रखना है मेरे को. तो बनाना तो 2 raised to power 5 ही है. The question is कैसे? Any answers? इसमें और इसमें डिफरेंस क्या है? 2 raised to power 45 और 2 raised to power 48 में the difference is 2 raised to power 3. So what I do is I write 2 raised to power 48 as 2 raised to power 3 into 2 raised to power 45. ठीक है? 2 raised to power 3 होता है 8. 2 raised to power 45 को मैंने लिखा 2 raised to power 5 raised to power 9 like I did in the previous case. 8 into 32 raised to power 9. Now divide the individual terms by 31. When I divide 8 by 31, the remainder will be 8 itself. Or 32 raised to power 9 divided by 31 was a remainder of 1. So यहाँ से 8 आएगा, यहाँ से 1 आएगा. Overall remainder 8 बन जाएगा. So when you want 2 raised to power 5 और power में 5 नहीं है, you take out the extra part, you'll get a small number which will be divisible by which will be the remainder when divided by 31, and you solve the remaining part. The next variation, we will increase the base of the numerator. And since you guys are actually answering questions, which is nice to see, I would want you to answer this question as well. Remainder when 33 raised to power 48 is divided by 31. Now, the base of the numerator is quite a decent number, 33. 33 की powers में raise नहीं करूंगा in the exam because it will take a lot of time. अगर 33 raised to power 5 निकालना पड़ेगा तो वो तो नहीं हो पाएगा. So what do I do? Not two. Power भी हम देखो, when I was getting a plus minus 1, the power did not matter in that sense. Magnitude तो 1 ही रहेगा. But 2 वाले केस में the remainder will not be 2 but 2 raised to power 48. So what I'm saying is, जब मैं लिख रहा हूँ 33 raised to power 48 divided by 31, देखो 33 can be written as 31 plus 2, right? Now every time I divide 31 plus 2 by 31, I will get 2 as the remainder. और 2 कितनी बार आएगा? 48 times. So यहाँ से remainder आया 2 raised to power 48. अब यार ये 31 से तो बड़ा है, इसको फिर 31 से डिवाइड करो. और ये हम इससे पिछले वाले क्वेश्चन में कर चुके हैं. 2 raised to power 48 when divided by 31 gives me a remainder of 8. The question right before this. Therefore, ये जो second question और जो third question है, technically they are the same. तो दिखने में अलग अलग लग रहा है, बेस न्यूमरेटर एक 2 एक 33 है, बट वैल्यू सेम है. ठीक है? तो ये this is the second type of variation where the initial value that I am getting is not a 1 or a minus 1, but something else. So I have to raise powers of the number to reach divisor plus minus 1 wala state. Now the third type of question. तो इसके लिए एक basic rule समझना जरूरी है. See, what is the remainder in 32 is divided by 24. Remainder आएगा 8. 32 और 24 दोनों को 2 से डिवाइड कर दो. रिमाइंडर व्हेन 16 इज डिवाइडेड बाय 12, रिमाइंडर आएगा 4, दोनों को फिर 2 से डिवाइड कर दो। रिमाइंडर व्हेन 8 इज डिवाइडेड बाय 6, तो रिमाइंडर आया 2, इन दोनों को फिर चाहे तो 2 से डिवाइड कर दो, 4/3 रिमाइंडर 1. So what happens is, as you divide the dividend and the divisor by a number, the remainder also gets divided by that number. Why this happens? Because dividend was divisor into quotient plus remainder. अब मैंने इसको डिवाइड बाई 2 किया, तो यहां भी पूरा डिवाइड बाई 2 होगा, ये भी डिवाइड बाई 2 हो गया, ये भी डिवाइड बाई 2 हो गया, तभी इक्वेशन रहेगा. सो इफ आई एम डिवाइडिंग दीस टू नंबर्स बाय अ नंबर, द रिमाइंडर आल्सो गेट्स डिवाइडेड बाय दैट नंबर. इसको यूज करते हैं. If I ask you what will be the remainder when 5 raised to power 35 is divided by 100. Till now in all the questions that we attempted, there was no common factor between the numerator and the denominator. है ना? 6, 7, 5, 6, 32, 31, 33, 31, कोई भी कॉमन फैक्टर नहीं था. यहाँ पे 5 raised to power 35 and 100 both have common factors. Both are divisible by 25. So whenever you're dividing numbers which have common factors, you first divide both the numbers by the common factor, find out the remainder, and then multiply. What am I saying? I am saying इसमें 5 और इसमें कॉमन फैक्टर है, क्या है? 5 कैन बी रिटन एज 5 स्क्वायर इंटू 5 रेज़्ड टू पावर 33 और 25 कैन बी रिटन एज 5 स्क्वायर इंटू 4. तो मैं बोल रहा हूं डिवाइड बाई 5 स्क्वायर, सॉरी, डिवाइड बाई 5 स्क्वायर. आई विल बी लेफ्ट विद 5 रेज़्ड टू पावर 33 डिवाइड बाई 4. इसका रिमाइंडर निकालना तो बहुत आसान है. 5 raised to power 33 divided by 4 का रिमाइंडर कितना होगा? 5 is 4 plus 1, so the remainder will be 1, and therefore the overall remainder will be. देखिए अगर यहाँ पे रिमाइंडर r था, since I am dividing both of these by 25, this will also be get divided by 25, and therefore it becomes 1. So the value of r will be whatever number I get here into जिससे भी डिवाइड किया था. So the answer becomes 25. So the third concept is, if there are common factors between the numerator and the denominator, this is how we'll go about finding out the remainder. चलो, now comes the concept of splitting the denominator. So एक set of questions ये हो गया, मतलब if just quickly I rewind the concept जो हम कर रहे हैं, what are the different types of questions. तो एक question हमारा था ये, the first question was this one, the last line, 4831, 4835, 4835, 33 divide by 20. I can have this kind of a question. दूसरा सक्सेसिव डिवीजन का क्वेश्चन हो गया. थर्ड टाइप ऑफ क्वेश्चन वाज नंबर रेज़ टू द पावर डिवाइडेड बाय अनदर नंबर. तो 7 रेज़ टू पावर 35 by 6, 5 रेज़ टू पावर 35 by 6. इसमें तीन वेरिएशन हमने देख लिए, 2 रेज़ टू पावर 45 by 31 एंड द कॉमन फैक्टर वाला 5 रेज़ टू पावर 35 upon 100, राइट? So this is question 1, 2, 3. In the third we look at 3 variations. Now is the fourth concept. The question says, what will be the remainder when 1, 2, 3, 4, 5, 6, 7 is divided by 36? So there is no power in the numerator. एक नंबर है और उसको हम 36 से डिवाइड कर रहे हैं. Can you tell me the divisibility test for 36? What will be the divisibility test for 36? देखो, क्योंकि इट इज अ कॉम्पोजिट नंबर, तो 36 को दो पार्ट में डिवाइड कर देते हैं, such that the product of those numbers is 36 and they have nothing in common. जैसे 2 और 3 को किया था, नहीं है ना, जैसे हमने 6 को किया था 2 and 3. So 36 can be written as 2 into 18. 2 and 18 में को प्राइम नहीं है, they have common factor of 2. Anything divisible by 18 will be divisible by 2. 36 can be written as 12 and 3. कॉमन फैक्टर है 3. 6 into 6 वो दोनों ही कॉमन है. 9 into 4. 9 और 4 have nothing in common, है ना, को प्राइम नंबर्स हैं. 9 into 4 is absolutely perfect. Chat में someone has written 4 into 9, 4 and 9, which is perfect. 4 into 9 is 36. So if a number is divisible by 4 and 9, 4 से भी divisible है, 9 से भी है, तो उनके LCM से भी divisible होगा, which will be 4 into 9, 36, right? So in a question like this, I am breaking down the denominator. 1, 2, 3, 4, 5, 6, 7 divided by 36. 36 is 4 into 9. So I check for those numbers. तो आप मुझे ये बताओ, अगर मैं 1, 2, 3, 4, 5, 6, 7 को 4 से डिवाइड करूंगा तो रिमाइंडर कितना आएगा? Divisibility test for 4 was the last two numbers. तो 67 divided by 4, तो 64 plus 3. अच्छा, पहले 9 से चेक कर दिया, बहुत ही बढ़िया. तो यहां से 67 डिवाइड बाई 4, रिमाइंडर 3 आ गया. इफ आई डिवाइड द नंबर बाय 9, 1 plus 2 plus 3 plus 4 plus 5 plus 6, 1, 2, 3, 3, 3, 6, 6, 4, 10, 15, 21, 28. So when I divide this number by 9, the remainder is 1. What will be the number? What will be the remainder when the number is divided by 36? Right? So what I do is, I find out the smallest number which satisfies these two conditions. यार 9 से डिवाइड करो तो रिमाइंडर 1 है, 3 से डिवाइड करो तो रिमाइंडर 4 है. हमें ऐसे एक नंबर निकालना है. What would be that number? I am trying outright hit and trial. I will start with the first condition. I will write numbers which when divided by 9 leave a remainder of 1. Which are those numbers? Right numbers at okay. 1, 10, 19, 28. 1 को 9 से डिवाइड करोगे रिमाइंडर 1 है. 9 plus 1, 10 को 9 से डिवाइड करेंगे रिमाइंडर 1 है. Plus 9, 19, plus 9, 28. For all of these numbers, when divided by 9, remainder is 1. The first condition is satisfied. कितने नंबर लिखने हैं? जितना दूसरा डिवाइजर है 4. अब इन नंबर्स को 4 से चेक करिए. 1 divided by 4, रिमाइंडर 1 रहेगा. 10 divided by 4, the remainder will be 2. 19 divided by 4, the remainder will be 3. This is what we needed. The condition is satisfied. So 19 is the smallest number which is divided by 1 leaves a remainder, which is divided by 9 leaves a remainder of 1, and when divided by 4 leaves a remainder of 3. So when I divide the entire number by 36, the remainder will be 19. I am sure you would not have learned this anywhere else. अभी तक कभी पढ़ा नहीं होगा. Would be a new concept for you. Basic numbers का application है. But I think a very powerful application, and a lot of questions can be created on this. चलिए, another concept that you have to remember is if you get stuck in a remainder question, always remember that numbers are cyclical. Any operation that you do in numbers will follow cyclicity. Why? Because what is decimal? What is, ये मैंने क्लास में पूछा, what is decimal? Point. Decimal is a counting system. The counting system that we use has 10 digits, 0 to 9. 10 मतलब डेका, 9 मतलब नैनो, 8 मतलब ऑक्टा जो होता है ना, वहां से डेसिमल वर्ड यूज होता है. So because we have only 10 digits, any mathematical operation that I do, eventually the digits will get repeated. For example, अगर मैं बोलूं कि यार मैं 4 में 4 को ऐड करता चला जाऊंगा, what will be the last digit? 4, 8, 12 का 2, 16 का 6, 20 का 0, तो 48260, उसके बाद फिर 48260 आएगा. Any mathematical operation will lead to a cyclicity, and therefore here if I say कि 7 की पावर है 9 से डिवाइड करना है, 7 raised to power 52 divided by 9. Now if I know the methods that we have or that we studied, इसको मैं सॉल्व कर सकता हूँ. 7 divided by 52 by 9 becomes 9 minus 2, तो 2 raised to power 52 by 9. 2 raised to power 52 को मैं 8 बना दूंगा. 8 से कुछ करके आंसर आना चाहिए, है ना? है स्टेप्स, बट मैं बोल रहा हूँ मुझे स्टेप फॉलो नहीं करने यार, मुझे याद नहीं आ रहा है. व्हाट डू आई डू? आई स्टार्ट चेकिंग. आई चेक द रिमाइंडर ऑफ 7 एंड डिवाइड बाय 9, तो वो 7 ही रहेगा. 7 स्क्वायर 49 का 9 से चेक किया तो 4 आ गया. 7 क्यूब का चेक किया तो 1 आ गया. 7 रेज़ टू पावर 4 का चेक किया तो 7 आ गया. देखो पहले भी 7 आया था, फिर 7 आया. अब अगर यहाँ 7 तो आगे 4 1 ही आएगा. द रेपिटेशन विल स्टार्ट. So for powers of 7 when divided by 9, the remainders will be 741, 741, 741, 741 and so on. तो अगर मैं सब कुछ भूल गया हूँ और क्वेश्चन मुझे अटेम्प्ट करना जरूरी है, I can just use this basic concept of cyclicity and say पावर बढ़ाते जाओ, रिमाइंडर चेक करते जाओ. The moment the remainder repeats, उसके बाद तो सेम ही रिमाइंडर चलने वाला है, right? So this could be one way of finding the remainder as well. If you get stuck and you have nothing else that strikes you, ठीक है? So I think आज के लिए बहुत हुआ. We have touched upon remainder 7, 52. Yes, remainder 7, absolutely. So we've touched upon some aspects of remainders. Whenever we have the next class, we will look at some formula-based questions on remainders and some practice questions on remainders. So in the next class that we have on YT Live, my expectation will be that you have gone through this so that you're able to answer questions, right? Good. आज तो अच्छा answers किए जिसने भी किया. So keep that up. And yeah, could you please explain why the remainder of 19 previous case? See, follow this concept. You will always get the answer, right? But if you want to know why, this number is of the form 36k plus some remainder, right? So when I divide by 36, r is the remainder that we have to have. अब ये जो r है, जब इसको मैं 4 से डिवाइड करूंगा, 36k plus r by 4, the remainder will be because of this r. By 4 the remainder should be 3. So this r should leave a remainder of 3 when divided by 4. When I divide this number by 9, 36 is divisible by 9, so the remainder will be because of r. When divided by 9, remainder should be 1. So r should leave a remainder of 1 when divided by 9. So हमने एक ऐसा नंबर ढूंढा which when divided by 4 leaves a remainder 3, which when divided by 9 leaves a remainder 1. वो 19 होता है. That is the answer, right? ठीक है जी. चलो, great. Good participation. Keep this up, and I'll see you soon. Until then, take care. If there is any problem, please get in touch. And all the best for your exams. Bye.